Hello students, so today we're going to look at some more logs, but today it's going to be graphing them. So today you're going to want to have pen or pencil, calculator, and those guided notes I gave you because we're going to be doing quite a bit of graphing today. So let's think back. Let's go back to when we were graphing exponential functions, which wasn't too long ago, but let's dig. So remember, you're just going to graph these points. So we got -2, 1.1, so that's about right there. -1, 3.3, that's about right there. 0, 1 is right there. 1, 3 is right there. And 2, 9 was right there. So then we knew that we would graph and it would connect. And we get a graph like that, right? So that's an exponential function. Now, graphing logs and exponentials are alike, right? We've been changing back and forth between the two functions. So what if we can't use that to graph an exponential function or graph a log function, right? So this is y equals log base 3 of x, right? So let's convert that into our exponential form. That would be 3 to the y equals x, right? So why can't I plug in for y to get my x? You're saying, whoa, Miss Marsh, that's a little strange, but it actually works. So I'm going to pick -2, -1, 0, 1, and 2 for my y values. Notice how I'm writing for my y's, not my x's. And I'm going to plug that in for y. So what I'm going to do, I'm going to go 3 to the -2 power equals x, right? 3 to the -2, if you type that quick into your calculator, you'll get 0.11. Same thing here, 3 to the -1 equals x. 3 to the -1, well, that's just 0.33. 3 to the 0 equals x. Well, 3 to the 0, you shouldn't even need your calculator for that. Anything to the 0 power, that is 1. 3 to the first, that's 3. And 3 to the second, well, that's just 9. So let's actually graph these points. So I got 0.11, -2. So I'm going to have 0.11. It's going to be like right there. Down -2, it's going to be right there about. Whoops. There we are. 3.33, -1, so about right there. 1, 0, there. 3, 1, and 9, 2. So let's try to graph this here. Let's put a line through here. It's going to go like that. It's going to run through, and it's going to go like that. Right? It's going to look about something like that. So my domain, let's look here. What x values are we intercepting? I notice I'm not touching any x values on this side. I'm only going on the positive. So x needs to be greater than 0. It can't be smaller than 0, so it can't be negative. It has to be greater than 0. All my y's, though, I'm hitting all the negatives. I'm going to keep getting bigger on this side, so it's going to give me positives. So I have all reals for my range. What about my asymptote? So my asymptote on this particular graph, I am not intercepting right here, right? So now, a lot of you are going to say, well, that's y equals 0. Unfortunately, it's not. That it intercepts the x-axis, so it's x equals 0. So log functions are always going to have an x equals 0 asymptote. And your domain is always going to be x is greater than some number. So here's some graphing comparisons that we've seen. Notice how this is b to the x, and this is how log of b of the x. They are actually inverses of one another. So that's really kind of cool that they're inverses. That allows us to go back and forth. That way we don't have to graph log base 3 of x, because that's really hard to graph. Imagine plugging that all into your calculator. You would have to use a change of base formula. It would take forever. That's why it's so nice to have these inverses. So here's the relationship. Our domain of our exponentials, if you remember, was all reals. Our range was y is greater than 0, and our asymptotes were y equals 0. All right? So now, what's cool about inverses? domains and ranges flip. Because remember, x and y's flip, right? So our domain that was originally is going to be our range. So that's why I have all reals for my log functions. Your range is going to become your domain. So we're going to have x is greater than 0. Since I have an inverse, my y needs to become my x. So my asymptote is going to be x equals 0. So it kind of makes sense a little bit how these two are inverses. They play off of one another. So let's graph these log functions, shall we? So let's change it to the exponential form. That's the very first thing I would do. So this f of x, that's just a really fancy way to write y. So I'm just going to scratch it off and write y there. So I know I have log base 3, so 3 to the y equals whatever this inside is, x minus 4. So this is going to take a little bit. This one's going to be a little difficult. But we're still just going to plug in -2, -1, 0, 1, and 2 for our y values. So never try to plug in for your x values, only your y values. So we're going to get 3 to the -2 equals x minus 4. Alright, so 3 to the -2, that is 0.11 equals x minus 4. So to get x alone, you're actually going to add 4 each time you do this. So you're going to get 4.11. Another thing you could do, if you want to just do it straight into your calculator, you could add 4 right away. So you get 3y plus 4 equals x. That's probably an easier method for you if you just want to pop this into your calculator. 3 to the y plus 4, and you can easily get it. 4.11, our next answer would be 4.33. With a 0, we would have a 5, 7 for a 1, and a 13 for a 2. Can't graph that, but that's okay. It kind of gives us an idea. So 4.11, -2. About right there. 4.33, -1, a little farther. 5, 0, 7, 1, 13, 2, which is like way out there. So let's go ahead and graph here. Sound effects are needed. So we're going to have that graph. Now, domain. What am I not crossing? I am nothing bigger. I'm only bigger than 4, right? So x has to be greater than 4. Your range, I'm hitting all y values, all y's. So your x's, notice how we have this right here. It moved 4 to the right. So my asymptote is x equals 4. So these two are going to be related. Just like last time when our vertical shift was related, it's going to be our horizontal shift. So you're going to want to think opposite on this part. Alright? So let's graph in our asymptote of x equals 4. It's going to be right here. Right there. Marvelous graphing, if I don't say so myself. Let's try this one. So y equals, because that's just a fancy form of y, equals 5 plus log base 3 of x. So very first thing I would do, get log alone. So let's subtract 5. So I'm going to y minus 5 equals log base 3 of x. Otherwise, it just ain't going to work. So let's convert this. I'm going to have 3 to the y minus 5 equals x. You're like, oh goodness, this is going to be a while. Not too bad, actually. So we're going to pick a number, the thing in the middle, just like last time. We're going to see what would make that equal to 0. 5, right? So we're going to put for our y value in the middle a 5. That way we know exactly how to graph this. And we're going to get a nice curvature of this graph. So 4 and 3 are smaller and 6 and 7 are bigger. So now we can plug in some values. So 3 to the 3 minus 5, well that's just -2. So 3 to the -2, that is 0.11. With a 4 there, we would get -1 here. So 3 to the negative 1, that's 0.33. 5 minus 5, that's 0, so we would get a 1. Plug in the 6, we get 6 minus 5, that's 1. 3 to the first, 3. And a 7, 7 minus 5, 2. So we're going to have 3 to the second, 9. So let's graph these functions. So we got 0.113, something like that. Oops. 0.334, 1, 5, 3, 6, and 9, 7. So if I graph my function here, whoa, that was pretty bad. That's okay though. So notice how I am not crossing over right here. I didn't move left or right at all. I just moved up or down, right? So my domain needs to be greater than 0. Notice how my x's are not bigger than 0, or not less than 0. They're only bigger. My range, all reals, just like last time, and my asymptote, x equals 0. All right? That is how to graph logs. This is Miss Marsh signing out.